Okay, this is number 37 on the Honors Algebra 2 SLO review, and it asks us to find the coordinates of the vertices and the foci, and then the slopes of the asymptotes for the hyperbola with the given equation. So the first thing we're going to need to do is complete the square. And if you look, I've underlined the terms with the x's, and I've underlined the terms with the y's. So I'm going to want to rewrite that so those are together. And then this plus 19, the constant that's there, the one that doesn't have a variable, I'm going to need to move that to the other side of the equation. So I'm going to go ahead and do that now. Now what we're going to need to do is factor. So for each of the pairs with the x's and the y's, if you look at the x's, in order to complete the square, the number that's in front of the squared term has to be a 1. So we're going to go ahead and factor out a 4. So we're left with x squared minus 8x. And keep in mind we're going to complete the square, so we're going to go ahead and put in that plus box now. For the y terms, usually the mistake that I see made on here is that a lot of times, people factor out the -9, but when they go to rewrite this, they'll forget about changing that middle sign, so make sure you don't do that because it's going to change the center of your hyperbola and therefore is going to really pretty much change everything else. So you want to make sure you're really careful about that. So we take out a -9, it becomes a positive 2y, and then again plus box, equal to on the other side -19, and to save some room here I'm just going to put plus 4 box up here. And then with the y terms, remember it's a -9, so it's -9 box for that. Okay, so now we just need to fill in the numbers that go inside the box. So if you look at the first one, remember you're taking half of that middle term and squaring it, so -4 squared. Over here, half of 2 is a positive 1 squared. Remember, whatever we do in one box, we got to do on the other side, so -4 squared and 1 squared. And I just really need to simplify it. So we have 4 and then x squared. Oops, that's not what I wanted. So we have 4 and then x minus 4, the quantity squared, minus 9, y plus 1, the quantity squared, is equal to, if we over here, if we take -19, we add 4 times 4 squared, and then minus 9, we get 36. And then the last thing we need to do is set this equal to 1, so everything gets divided by 36. When you look at this, the right side of this is going to reduce to a 1. And if you look on the left side, 4 over 36 is going to reduce to 1 over 9. And then 9 over 36 is going to reduce to 1 over 4. Alright, so we have the standard form for what we need to graph for this hyperbola. So I'm going to go ahead and rewrite this so it looks a little cleaner. And we're going to go ahead and go through and find the center and the vertices. Okay, if we look at the equation of this, we can get that our center is going to be the point 4, -1. And I'm just looking at my key, and apparently I graphed it at -4, -1. So if you looking at the typed solutions, I think the vertices and stuff are off a little bit, so I guess we'll fix that now and then maybe reprint the key again. Okay, so I'm going to need to adjust my graph, so give me a second. Okay, so we're going to go ahead and plot our center at 4, -1, and I went ahead and changed the scale on my graph because this grid's so tiny. So 4, -1 is going to be right there. Okay, and now we need to go ahead and draw the rectangle that goes with this. So remember, you're going to look at the first term over here, and we have x minus 4 over 9. So since the x is first, that means our vertices are going to go left and right. And we're going to go left and right 3 from the center. So since the denominator of the x term is 9, take the square root of it, and you get 3 and 3, so that'll give you essentially the radius on each side. So from that center point, I'm going to go over 3. 1, 2, 3. Again, my scale is every 2 is unit, and then 1, 2, 3 the other way. Okay, so those are my vertices. The vertices are going to be the points that we draw the hyperbola off of. All right, so those are the points 1, -1, and 7, -1. All right, so on my key, the one that I typed up for you guys, it says -1, -1, and -7, -1. That's wrong. This one's right. Okay, so now we need to go up and down from that point. We're going to look at what's underneath the y-coordinate to tell us how far up and down to go. The square root of 4 is 2, so we're going to go up 2 and draw a line, and we're going to go down 2. Okay, so the distance between the two green bars, that is your conjugate axis. I know this one doesn't ask you for that, but and then the one that attaches the two vertices, that's going to be your transverse axis. And remember, for these, the bigger one doesn't matter. That's the only thing that's a stipulation for the ellipse. With the hyperbola, it's just a matter of which variable is first in your equation, which one's positive. Alright, so I'm just making my rectangle for this. And then I'm going to attempt to draw in asymptotes that hopefully don't look too bad. And then the other direction. And then your hyperbola curves, remember this is why we do the dots on the vertices and we do little dashes on the other side. Your hyperbola curves are going to go left and right. Sometimes if you don't put those dots, if you put dots on all 4 of those, you kind of forget which way the hyperbola curves are supposed to go. Alright, so that's our graph. Now we just need to go back and figure out our foci. And our foci are going to fall somewhere on the outside of those curves. So not within the rectangle, but on the outside. The equation for the foci, you're going to have your formula sheet, so you don't need to remember about memorizing these formulas. If you look at it, it's a horizontal hyperbola, so it's going to be h plus minus c and k, where c squared is a squared plus b squared. And we have a squared and b squared already from our equation. So really c squared is 9 plus 4. So c squared is 13. So what we're going to add and subtract from our h term is the square root of 13. H, remember, is just the x-coordinate from your center, and k is the y-coordinate from your center. And now we know this is plus minus the square root of 13. So it's going to be 4 plus minus the square root of 13 and -1. So those, if you were to plot those should fall somewhere in here. Again, I'm just estimating, but they should fall somewhere inside those curves. The last thing we need to do is the equations of the asymptotes, and that's the equation. Start a new page. Y minus y1 is equal to plus minus m times x minus x1, and that formula is on your formula sheet. It just doesn't happen to fall in that section for the hyperbola. And really, when we're talking about the asymptotes in this conic section, it's really y minus k, and then plus minus the slope of x minus h. And that's just to show that you're just using the center for that. So remember, your center was 4, -1, so that's your h and k. So we can go ahead and plug those in. Y minus the -1 is really going to give us y plus 1. And over here, we'll fill in the slope in a second. But then x minus your asymptote, so x minus 4. Somehow I managed to get this one right on the key. That's what you get for not triple checking your work. But if we want to figure out the slope, really we just need to go back and look at the equation at our hyperbola. And if you look from the center, if you count the rise over the run from this center dot to really any of the corners, because we're going to do plus minus, if you look at the picture, you're going up 2, so your rise would be 2, and over 3, so 2/3. Another way you could do that is if you look at the denominators. So we had a 9 underneath the x term, and we had a 4 underneath the y term. Remember, rise over run. So the rise comes from underneath the y, because y is the up and down coordinate, and then the run, the horizontal movement, comes from underneath the x coordinate. So you can always look at the square roots of those to get that. Alright, so there's the equations of your asymptotes. If I want to go back to the last page so you can see it all together, you're going to have y plus 1 is equal to plus or minus 2/3 x minus 4. That's it.
Made with Doodlecast Pro.